Hi, my name is Waira Brian. I work with Nexus Green Limited as a driver. I'm happy to be in Katakwi Agule village. This is one of our many projects that we have all over the country, and it's an irrigation scheme. This irrigation scheme is designed to have about 20 cubic meters of water per hour.
We thank God that now we are able to speak while seeing that the irrigation scheme is here.
With the laser spray tips that have been installed on these gardens, the farmers have been able, or they are now growing watermelon, which is expected to improve their daily incomes and also improving their livelihoods.
Each 5 hectares can benefit about 40 farmers. They can grow 2 years and then get enough money and go and set up their own.
Communities are going to benefit in such a way that they will be more focused on high-value crops.
Our imagination is far much better than it was before.
We have a joint inspection visit, and this has brought together our stakeholders, the Ministry of Water and Environment, the district leadership, the sub-county leadership, the community and the local council executive. We are happy to be here today.
If you want to plow, you remove these, you roll them to the center, then the tractor, now the land is free for tractor, it can pass and plow.
Like that,
then you roll them back.
That's great. So the land goes this side.
The land goes there, all that cleared part is installed. We have 5 hectares or 12.5 acres. Yeah.
Our ministry has kick-started or initiated the activities, training farmers. They've formed them into groups, and they are being trained on how they are going to manage the system.
We have got the lake, and we are picking water from the lake. So the levels and the depth of the channel is all designed in a way that it is going to take water, to tap water at the minimum when water recedes in the dry season. This is an intake for extracting water from surface water sources. An intake is basically a structure that safely gets water from the water resource, especially surface water sources, and for irrigation purposes, and accommodates the pump so that we're able to extract water in an environmentally friendly and socially friendly manner.
This scheme is particularly based on a pump, which is abstracting about 25 cubic meters of water per hour. This can be able to generate the required energy, that is attracting the sun, generating the required energy to pump the required amount of water to the reservoirs, then to the gardens.
When we are designing this intake structure, we consider, first of all, the resource. We come and make sure that we study it properly. We have to take the minimum and maximum levels. We know where it floods up to and where water can recede up to, so that we tap from that point. So the intake point, the actual intake point is far from here, where we are standing, and it goes into the lake. So water is supposed to come by gravity. Water has to naturally flow to the swamp. So if it is naturally flowing to the swamp, it gets clean, like you can see, naturally. So we don't have a filter yet as it is coming. So it settles, drops whatever it is carrying, because it's not on speed, it comes slowly. So it becomes light. But we know that when it is coming, slow as it may be, it carries stuff along it. So we put the filtration units. So the primary filter is here, and it is a grating. So it has some small spaces, and it blocks any floating material from going through. So as you can see, this material. So the farmer has always to come and clean it off and take it away, so that this does not now go to our sample. I can actually call it a tertiary filtration because it is the third at the line. Then we have what I can call if there are two, it will be the primary, but now this is the secondary, because we have another filtration in the pipe that goes to the sample. So this one has smaller holes, and it captures finer pieces that may have escaped from the primary filter. So it is blocked here. So why we don't put this first is because we don't want to create a blockage.
This scheme one, it has a level of automation. It's what they call a pressure switch to guide you when the water is full in the tank, so it cuts off to prevent overflowing
and pumping unnecessary water. Then the pump itself has what they call a dry run protection. Whenever the levels go down, the pump will always come off, this prevents it from getting damaged because of running dry.
The channel width, the channel length, and the size and the depth are all calculated to make sure that they bring in the water that we need. The amount of water that we want must be the one to come to the system. Water comes here into the sump. The sump depth, normally they are ranging between 7 meters to 11. So depending also on the pump we are using and the water that we need and the depth that we have from here, the differences in elevations from here to the water source where we are tapping water from. Because the point in design is that at any one point, this resource shall never run dry. We design to safeguard both environmentally and socially. So we make sure that we have this fence around to be able to protect people from coming in and falling in. Then we have a gate which we are going to lock, so unauthorized access is not possible. So anyone who comes here has a reason why they have come here, and they are expected to be careful not to fall in, because some of these components can be so deep that somebody can drown in there. So this is our pump station. It has the pump, the solar array. So we are powering the pump from here. In here we have, of course, the solar panels, we have the connections, we have the lightning arrestor. So this is to protect this system from being struck by lightning, since it is an electrical system. It is prone to attracting the charge from the lightning. So we put this to arrest everything to the ground and ground it. And then we have put machine crush stones to make sure that we don't have splash. If it rains, the splash does not come to the panels, and also the water coming from the solar panels can drain again back to the ground. We don't have to create runoff because we have put it. So that's part of the environmental friendliness that we talk about. When you go here, so the pump now delivers water through this pipe. Then it goes inside. There's a set of wellhead fittings, as we shall see. We have access to the pump. So this is the store, and also the guardhouse, for now being used as a store. So this is the pump house. So this is the panel specific information, and then we have the water source. Almost all these elements that we use: design depth, the head, the water pump specifications, the Jinko pump. This is an inverter, which is a smart one. It is the one that receives power from the solar panels and then transfers it to the pump, and it is the one to control it. So here, the water comes through this to the air brief valve. This is to remove all the air. Then it is measured. We know the pressure coming through. So here we can see it is almost 40 meters head coming through, or 4 bars. We designed for the flow to come when it is clean, when it is laminar, not turbulent, because fittings cause turbulence in the flow. So we put these 2 spool pieces to make sure that the flow is coming smooth to be measured. Then we have a washout in case we need to empty the line to do something maintenance on it. We open here, and the water will throw outside, and we empty the line. We are able to work on it when it is not having water. So basically, this is all about the pump house, and that's the system.
I am impressed on what I'm seeing. I see there is good work done. Didn't see natural rain, but you find the places were green everywhere. So you brought it here. I'm grateful for what I've seen.
We believe this can support education, support our livelihood, and the rest of the families will benefit, and actually life would change.
Nexus Green aims at giving water throughout the seasons. It is all about having a continuous harvest without any hindrance. Don't forget to like this video, share and subscribe.